Okay, so continuing on with our discussion of equivalent resistance from the last video. In a parallel circuit, the more resistors you add, there's actually less equivalent resistance or less resistance total. And this is because there are more paths for the current to follow, and it can choose the path of least resistance. We can imagine the resistors as one big resistor, just like we did with the string of lights. And the way we do this is different from the series resistor where we just add them together. The equation looks like this, where there's an equivalent resistance and it's equal to the sum of the fractional values of each resistor, or like the inverse of each resistor. So it would have to be 1 divided by resistance 1 plus 1 divided by resistance 2 plus 1 divided by resistance 3, etc. So however many resistors you have, whatever numbers go in here, you use a fraction instead of just adding them all together. So what is a short circuit? We've already kind of gone over this in previous videos that I've shared with you. But a short circuit is a wire that bypasses a device in a circuit. And just like I said earlier, electricity is always going to pick the path of least resistance. So since wires have no resistance, or virtually no resistance, because they're really good conductors, the electricity is going to go through the wire rather than a device. So this is what a short circuit would sort of look like. If you had, you would kind of say this is in parallel almost, but there's no resistor on this path. So it's going to want to go through this path that has no resistance instead of taking all this time and all this energy to go through the resistor over here, which is the light bulb. Light bulbs are resistors, if you do not recall. But wires don't have resistance, so they're just going to go through the wire. So, as I said on that slide before I move on, as I said on that slide, almost all the current goes through this little shortcut here. And the reason why we don't want to do that, there's actually 2 reasons. The battery gets drained a lot faster because all the current just keeps going and going without any restriction. And the wire will heat up, possibly melting the insulation, and that could start a fire. So you don't want your circuit to look like this ever. You want to take out this wire here and just have your 2 resistors over here. If you have a wire that looks like this, all the current's just going to go this way, and it's going to go unrestricted, free-flowing, until the fire starts. So that's pretty much it for what you need to know about circuits, and this will come in handy when we do our lab next week.